Hello folks and welcome to our last video. Woo woo. So we're talking about bone structure and chemical composition. Now we've already talked about chemical composition and the extracellular matrix, and it's made of two different components. We said it's going to be the inorganic hard part and also the organic strength or flexible portion. So we also said that the inorganic part is going to be made of hydroxyapatite here, and the organic part is going to be mostly made of collagen. So yes, the bone is a composite. It has an organic flexible layer and an inorganic hard layer, allowing it to be both strong and tough. So let's focus on the organic layer, which we already said is only 1/3 of the overall composition of the extracellular matrix. Again, mostly collagen. And of course it has bone cells, and the whole goal is that it's going to resist pulling and twisting. So it's going to be resisting tension. Okay, that's why it's super strong. Now, the inorganic part is going to be the majority part, or 2/3, and that's going to be the hard part. We already said it's made up of a hydroxyapatite, which is going to be that calcium phosphate crystals and other minerals that are packed around the collagen, okay? And its whole job is to resist squashing or compression and to make the bones hard. Now remember, minerals help the bones last long even after death. That's why when some folks be out here being like, oh my gosh, how do we get a full-blown skeleton after someone has passed away? Well, think about it. The organic part is going to be able to decompose because there's plenty of enzymes and things within the soil itself. But the minerals have the ability to persist because they're relatively stable when buried in a normal way. Okay, so that means they're going to resist decay. Now, if you have somebody out here that was, unfortunately, if you watch a lot of crime shows, they were like thrown in the water or river or something like that, or if they were in soil that was more acidic, then you would definitely see a lot of those minerals start to dissolve, or if they were in some kind of acidic soil, right? But if we're talking about somebody that was literally just wet, then what's going to happen is those minerals are going to end up leaching into the water around it. And so that's going to make the hydroxyapatite become weaker. And if it's weaker, then of course it can decay faster. Okay? But if it's buried in a certain way, it can have a situation where you can go from a stable skeleton to an actual fossil. Okay? So that just means that the mineral framework is going to survive. So the hydroxyapatite is going to survive. And also you have situations where the hydroxyapatite is replaced with minerals from the soil around it, and they can form these fossils that can be thousands or millions of years old. Okay, so that's what's pretty important about the hydroxyapatite in the inorganic portion. So a lot of times that's how we keep our skeletal system intact if you're buried in a normal way. And that means soil that's not acidic. But of course, if you're in a casket, then it also is going to cause extra protection for that decay to not happen as rapidly. Now, if you're in some environment that's wet, of course, you'll have leaching of minerals, which again will compromise the structure. If you're in acidic soil, yes, you're going to have that pH decrease, making things acidic. If it's acidic, it's going to break down the hydroxyapatite or the minerals faster. And of course, if you're in hot environments, that will help basically break it down as well. Now, one thing I want to show you here is just like little infographic, and this is going to show you the overall. Let me make sure I rewrite that. The overall composition of our extracellular matrix. And then we're going to go into the inorganic / organic parts. I don't even know what that is. I'm literally tripping. I'm getting to the last video and start acting a fool. I apologize. Our inorganic and organic parts of the actual extracellular matrix, and then we're going to focus on protein of the extracellular matrix, and then finally we're going to focus on our protein types. And at the bottom here, it's going to be all of our elements or different molecules that are going to be key and or have a specific abundance are going to be key in the overall extracellular matrix. And so the most abundant is going to be like our calcium and our phosphate. Okay, I'm literally tripping. To, of course, our least abundant. Let's get into some of these details. So overall, we know that majority of the actual extracellular matrix is going to be hydroxyapatite, and then we have other components, okay? Those other components can definitely be lipids or fats and water. but the organic protein portion is going to be made of different proteins, and we'll get to that next. But the inorganic portion is going to be part of our extracellular matrix. So overall, we see that hydroxyapatite is the majority. When we talk about what parts are going to be inorganic or organic, we know it's going to be 2/3, whereas the organic protein is 1/3, and there's also going to be some other components that have a smaller percentage. Now, of the organic protein, we always talk about collagen, right? So 90% of the organic portion of the extracellular matrix is going to be collagen. So that is majority here. But then you also have things that are non-collagenous, and that's going to be the extra, I'm talking about collagen, non-collagenous, and that's going to be the extracellular protein here that, again, is made of mostly extracellular matrix protein and cell protein. So let's look at some of the most abundant elements that we have, which we already said, calcium and phosphate. Then it's going to be carbonate and sodium, that's the most abundant. Then we're going to get into magnesium, potassium, and fluoride. And fluoride is going to be our least abundant element. And so this is just going to help us understand more details, or at least connect the details we saw before about chemical composition, and hopefully this helps. We have made it through chapter 6. Next week it's all about chapter 7, where it's about really understanding the structure, function, and location of different bones and the axial skeleton and the appendicular skeleton. See you next week.